Okay, good morning, Mr. Lesham here, and we are carrying on with the nature of roots. Okay, I've written here on the table, and I did it together with you a minute ago, a recap of how we answer these questions. But let me stress it again. Okay, when you're given the question and you're asked to comment on the nature of the root, you don't need to solve the question. You don't need to solve the equation. You don't need to find the roots. You just need to say, how many roots are there? 2, 1, or no real roots? Are they rational or irrational? That's all you got to do. And it's all to do with calculating the discriminant. Okay. So the more difficult level question is where you get an equation, okay, quadratic equation, okay, but your A, B, and C's, one of them, maybe all of them, might not even be numbers. Okay. So here I've got x squared minus mx plus 2x plus 1. I'm going to rearrange it slightly if you don't mind. I'm going to write the 2x before the mx, so 2x minus mx plus 1 equal to 0. And now, just to be able to see what's the coefficient of x, I'm going to pull x out. So it's going to be 2 minus m, x plus 1, 0. Now it's very clear, I hope for you, that the a is 1. Okay, this is your a. Let's write it down, what the a, the b, and the c. A is equal to 1. B is equal to what? 2. What is B equal to? 2 minus m. It's the coefficient, the things you multiply x by. And C is equal to 1. So we don't even know what B is. It's something with m. So the question here is slightly different. The question is not comment on the nature of root. Don't tell me if you have 2 roots, 1 roots, or whatever. The question was, for which values of m, x have equal roots. So I need to find the values of m that x have equal roots. So what I got to do, as always, I have to find out the delta. Okay, so let's find out the delta. The delta is going to be b squared, 2 minus m squared, minus 4 times a times c. Okay, we got to find that out. Okay. We're going to use the formula here, yeah? I'll pause as a question. Thank you, Buzwe. C is equal 1, so I shouldn't write C. Okay. So now we're opening up, okay? 4 minus 4m plus m squared minus 4. All I did is use that formula for a minus b squared. Okay? Right, we can tidy it up now. Delta, that's m squared. 4 minus 4 is 0, minus 4m. Okay? So that's my delta. I can't calculate the delta because I don't know what the m is. If you give me an m, I'll calculate the delta. But that's not the question. They're not asking me how many roots there are. Currently, we don't know how many roots there are because I don't know what m is. The question is for which values of m I will have one equal root. So to have one equal root, what does delta have to be?
0.
0. Okay, one equal root, delta equal to 0. So in other words, to have equal roots, delta must be equal to 0. In other words, m squared minus 4m equals 0. That's an equation now for m that I'm going to solve. That's an equation for m. Okay? That's an easy equation. Now we learned that from, I think, grade 9. Okay? We pull a m out, m minus 4 equal to 0, and the answers are m equal 0 or m equal 4. And that's the answer. If m is 0 or m is 4, okay, if you substitute here, you'll get equations that have equal roots. I'm going to pause here. Okay, guys, we're moving on. So far we looked at quadratic expression that looked like this. ax squared plus bx plus c. Now, already a few lessons ago, we learned to do something really cool. I thought quite difficult, but you handled it very well, which is called completing the square. And if you look back at what we did to complete this square, what we did is we changed this business into something that looked like that. In fact, it was more like this. Okay? It was something times x plus something, all of that squared, minus another number equal to 0. But obviously, if I want to do that, all I got to do now is plus d, and now it's going to look like that. So the question is, and I'll just show you by putting in an example. x minus 1 squared equals 7. Let's say something like that. And the question will be again, if they ask you to solve it, then you know how to solve it. You use the formula, you factorize, whatever you want to do. But they will ask you is comment on the nature of the roots of this equation. Now, at this point, this equation doesn't look like that. Right? I don't know what the a is because I don't know what x is squared. If I want to know what the a and the b and the c, what do I have to do? What will I have to do? I have to time and I have to simplify. X squared minus 2x plus 1, move everything to there, like we did in that last really nasty example. But now I'm going to, and you can do it, there's nothing wrong with that. But what I'm going to give you now is a set of rules to use when the equation is complete, the square is completed. So it looks like this. See, you've got x minus 1, something, x with something squared equal a number. And actually the rules turn out to be more simple. I'm going to first of all, differently this time, I'm going to give you the rules. We're going to look at it in a question, and use them in a problem. And then later on, maybe I'll try and explain where these rules come from. So just like we had here, A, B, and C were numbers, now I have different numbers, N, and D. And here, we just look at D. Okay, we're not calculating anything, it's just D. Okay, so it's all about the D. Okay? When the D is larger than 0, let's guess. When the D is larger than 0, let's just take a guess. How many roots do you have? 2, you're right. 2 real roots. All these rules work on this number, D. If D is equal to 0, one root, or 2 equal roots.
Is
one
it like
root,
delta?
Is it the same?
2 equal roots. Eh?
Is it the same as
It's the same, but instead of calculating the delta, which is b squared minus 4ac, it's just this d. Okay, d smaller than 0? No real roots. Okay, if d is a perfect square, they're rational. And if it's not perfect square, irrational. Okay, so you see it's exactly the same thing, but instead of calculating the delta, b squared minus 4ac, I'm just looking at the d. Okay, let's use it for this question. As it stands there, what is the d equal to? See that? You need to look at this and look at that. What is the d? 7. Okay, so comment on the nature of the roots. How many roots are there?
2.
2 roots, therefore, let's use the rate. Therefore, 2 real roots. What else you need to tell me? I'm not going to ask you.
Irrational.
They're irrational. Because 7 is not perfect square, they're irrational. Boom!
So,
Done! No, they didn't ask you to solve, they just asked you to find the nature of the roots. Let's make another equation. Just make it up. 2x minus 3 square equal minus 2. You know what? Make it more difficult for you. Plus 2 equal to 0.
Right.
Okay?
One.
Okay. First thing, I need to turn it into that form.
So you just have to take the 2 across.
Yes. Minus 2. And now what can we learn? What is the d equal to?
minus 2.
Minus 2. In other words, I have no real roots. Do I need to mention anything about rational or irrational? No, because there's no real roots. Because d is smaller than 0, no real roots. Yeah?
So we just get it to like look like that.
Look like that. So there's no point in opening it. Like Bruce said, we can just open it up and then I force it to there, but you don't need to. Okay, let's make up another one. Do you want to give me another formula? Let's say minus 3x plus 2 squared minus 9 equal to 0. Okay, how are we going to write it? What should we do?
Just take the 9 across.
Take the 9 across, so it equal 9. D is equal then to?
2 real roots.
What is D equal to?
2 real roots.
What is, yeah, but what is D equal to?
No.
9. That means I have 2 real roots.
And
Irrational.
there are.
They are rational because that's a perfect square. Okay? Now I want to just show you. Okay, maybe one more example. One more example. Let me just pause here. We're going to discuss and try and explain these rules a little bit. 2x minus 3 equal to 0. What is d equal to? 0. In other words, what do I know about this?
One solution is
No real root.
Okay, no, one root, one real root, equal roots.
Equal root.
Is it rational or irrational? It's rational because 0 is a perfect square. Okay? Rational. Okay? Now let's have a look. Take a minute and try and understand where these things come from. Okay? Let's write the general case. No, let's not use the general case. Let's just take a couple of specific cases. So if this is equal to, let's say, 9. Okay? Then obviously how many roots will I have? 2.
2.
Okay? Now, I want to find x. So what I've got to do is I'm going to move it over here. 2x minus... By the way, this is just to try and understand the rule. You don't need to understand it. Some people love it. Some people don't mind. So if you don't understand what I'm going to say now, don't worry about it. It's just I'm trying to explain why the d is the main thing. Why the d is the main thing. Okay? So let's have a look at like this. Maybe make it easier. I'm squaring this number. Is this number positive or negative? When I'm squaring this number, is it positive or negative? Positive. So a positive number equal to positive. Is that possible?
Yes, sir.
Yes. But in fact, I'm going to have 2 solutions. Why? Because if I rearrange that, I can write it like this. Minus 3 squared equal to 0, right?
Yes, sir.
And then I can use the difference of a square, 2x minus 3 plus 3 times 2x minus 3 minus 3. Just doing a difference of a square. And now I have 2 solutions. Okay? Okay? Don't worry if you don't get it. Let's not worry about it. Okay? Let's change it. Let's say this was negative. Can I solve this equation?
Yes, sir.
Okay? What's the side here? Is negative or positive? Negative. What is about the side here? Positive. The square of any number, whether it's negative or positive, is positive. Can a positive equal to a negative? No. So no real roots. I'm going to stop here because I can carry on, but I know it's a bit confusing. You know, all I want to give you an idea here is that d is the important bit. Okay? You got that, okay? mx plus n square equal d. It's all about the d. If the d is positive, great. We're going to have two answers. If d is 0, there's only going to be one answer because that means this whole thing has to be 0. If d is negative, no ways. You're never going to have an answer. If d is a perfect square, then I can square root that. mx plus n equals square root of d. Look, I've done that. To find out what mx plus n, I'm doing square root of both sides. If d is a perfect square, then this is going to be a rational number. In other words, the roots are going to be irrational. If d is not perfect square, it's not. Okay? I'm going to pause here. So just like with the other equation, when it was in this form, we had simple questions where knowing what A, B, and C is, tell me they're real, not real. Okay? Then we moved on to another class question when the A and B and the C, there was some M hiding there, or some kind of letters. Now we've got a similar situation here, but it's still easier. Okay? So they give you this equation. 3x minus 1, all of that square, equals C plus 3. But we don't know what C is. Can I tell now if it has real roots, 2 real roots? No, because I don't know what C. Give me a C and then I'll be able to tell you. For example, if I tell you C is 1, then what do I know about the roots?
Real.
There will be 2 real roots, right? Because 1 plus 3 is 4, is larger than 0, so there are 2 real roots. And I can tell you more, they're rational as well, because 4 is part. So I don't know what the C is, but that's not the question. The question for which values of C, the first part is, we have real roots. So what is that? That's going to give me some kind of condition on C. Okay? This is my D, right?
Yes, sir.
To have real roots, what does D have to be?
Larger than 0.
Okay, I need to kind of make it more clear. If I want to have two real roots, then D must be larger than 0. If I want to have just real roots, it could be 1, it could be 2. Then what do you reckon D needs to be?
Bigger than or equal to.
Or equal to 0. You understand what I'm saying here? Okay? So if they ask you two real roots, yes, D larger than 0. But if they ask you real roots, whether 1 or 2, then it needs to be larger or equal to 0. Equal to 0 is still giving you a real root, just 1. So now I need to make an equation on C. Okay? C plus 3, which is my D, needs to be equal, or what does it need to be? What kind of equation do I write for it?
Equals 0.
No, if it's 0, then I have one real root.
Equals.
Larger than 0.
Larger, if it's larger than 0, then it's going to have two real roots. But they're not asking for two real roots, they're just asking for real roots.
Equal.
Larger or equal to 0. Okay? And then I solve it, and I've learned that in grade 10, I think. I just move the 3 to the other side. I'm doing minus 3, not time. So I'm not changing the crocodile. Okay? So C is larger or equal to minus 3.
That's it.
That's it.
Okay.
Okay? We happy with that?
Yes, sir.
Just so you
Let me just pause. Yeah. Now, the same question they asked me, what is the condition on C to have equal roots? To have equal roots, what do I know about D?
Must be equal to
Must be
0.
to 0. But what is D? D is C plus 3. So C plus 3 must be equal to 0. In other words, C equal to negative 3. Okay? Lastly, no real roots. What does the D?
Less than 0.
Less than 0. So in other words, C plus 3 must be less than 0. In other words, C, how do I solve this inequality?
Minus 3.
It's minus 3, and what sign do I have?
Larger than.
Well,
minus-
which, I keep it the same. C is smaller than minus 3. Okay? Pretty easy. To summarize, okay? If you got a quadratic expression that look like that, don't use this. Use the delta we learned last lesson. If it's already set up like that, the only thing that matters, like you guys say, is D. I don't care about the M and the N. Okay? If D is larger than 0, you're going to have two real roots. If D is larger or equal to 0, you're going to have at least one real root, 1 or 2. If it's equal to 0, you're just going to have one real root. If it's smaller, no real root. If it's a perfect square, it's rational. If it's not a perfect square, it's irrational. Thank you very much. Back in the test.